This is a typical Inventor part. It's only got a half a dozen or so features. If I look at the parameter table is really where all the knowledge of your part is stored. If you haven't introduced yourself to the parameter table yet, you're missing out. Anyway, if I look at the model parameters, this is pretty much the way most people build parts, and this is the way they look when you're done building a part if you did nothing special. You'll notice I have all my D numbers here, D0 through D19. You can see where they're consumed. Some of these are in Sketch 1, some of these are in Sketch 2, some are in the ribs, some are in the mounting holes, some are in fillets, etc., etc. And you can see that the numeric input is just straight numeric input. I don't have any formulas, don't have any math, don't have any equations. This part really has nothing special in it, which, by the way, if you say File New Part and you build a part, you're pretty much going to have a look just like this. So the first thing I'm going to show you is how to add a little bit of intelligence into this panel. Because right now, if it wasn't for the Consume By section, I couldn't even tell you where half these dimensions are used. Little hint, I did not build this part. I just happened to be using it for a demo. I have no idea who built this part. But I see it's in metric. I see a lot of numbers here, like mounting hole, 3, 4, 2 millimeters. I have no idea what dimension's doing what. It's kind of all Greek to me at this point because I just don't know. If you're not the one that built it, it's kind of hard to tell what's going on. So what can we do about this? Well, let's take a look at it. A lot of times I will actually start at the part and say, where is what? So I'm going to look at the very first feature here. Right click, edit sketch. That tells me a little bit about the part. I can see it's an L shape that's been revolved. That's going to make that hub shape. But what you can do here is you can take any dimension that you want to control or be accountable for or set as a preference. You can take D0 here, 80 millimeters. I can double click on that and just very simply give it a name. I can call it a flange diameter. All you have to do is put an equal sign behind it to where your statement says flange diameter equals 80 millimeters. Now, I'm not changing the size of it. What I'm doing is I'm changing this D0 to where it says flange diameter. I'll do it again in case you missed that. I can come up here. I can call this a hub diameter equals 15 millimeters. What that's doing is it's renaming your D number to a name. Up here, there used to be D1. Now it's hub diameter. I could do the same thing for the heights here. I'm not going to be messing with the heights today. I'm just going to be messing with the diameters. So I can basically put names on some of these. I can leave the others alone. I'm also going to be looking at this rib today. So I'm going to right click on the rib, edit sketch. Looks like it's got a couple dimensions in it. This one is going to be the rib height equals, and this one is going to be the rib length. Rib length equals. Hit finish. So what exactly did I just do? Obviously, I did not change the model, but when I go to my parameter table, you will notice 4 of my D numbers now have official names on them. I found a long time ago it is much easier to track important information in your part with names than it is to try to memorize a bunch of D numbers. So there I've got everything named. And if these are important to you and the rest of the dimensions don't matter, they've got little filters down here. I can just say, show me the ones that are renamed. And it's only going to show those that have names on them. So now I've got the important information right in front of me, so I don't have to hunt for it. I'm going to go ahead and open that back up to everything. Just a toggle switch, turn on and off as needed. So I've got everything named. I've got a toggle switch. I'm going to add a little bit of flange diameter. This thing's currently 80 millimeters. I'm going to add another 50% to it. We'll go from 80 to 120. So I change it to 120, hit done, and I'm out here looking at this flange. Now, your company may have certain rule criteria. I know every company in the world does. It could be something as simple as a bracket, but you've got rules that go along with that. The more weight you put on it, the beefier it has to be. Just like this flange, the bigger the diameter, those ribs really need to go further out on that diameter. They're not going to support much out here on this outside flange. So if I'm going to make the flange bigger, it would be kind of nice if these ribs got bigger with it. That's what we call basically, design-based, rules-based programming. You want to write a statement in here that says, if the flange gets bigger, I need the rib to get bigger. Little things like that. It's not a big secret. It's just something we deal with every day. Well, the way this part was built from scratch, I'd have to go in here and change the flange diameter. Then I'd have to dig through the dimensions and try to figure out which one is the height or the length of the rib. It's easy when you named it, but imagine not having a name on that. You're trying to figure out which number to change to make that rib longer. And then if you do make it longer, how much longer does it need to be to go out like 75% of that flange distance? That gets into a little math issue. So how do we do that? Well, real simple. The way I like to do it, and I would highly recommend this, I'm going to add a user parameter. Now, technically, I can come up to this equation line and start typing in all kinds of math equations. Yes, you can do that. I have kind of a little bit different approach. I don't consider myself a programmer, but I've done programming in my past, so I have kind of a safe approach. I like to come down here and add a user parameter. So the first parameter I'm going to put in here is, I'm just going to call it a rib length formula. So I can come down here and actually experiment with my math. I'm horrible with math. But sometimes when you're writing equations, you do get into math, right? So I'm going to come down here and say, okay, I need to take the overall flange diameter. And it's real easy since I put a name on it. I want the flange diameter. I'm going to subtract from that the hub diameter. I apparently spelled them right because it's showing up in black. So I'm going to take the flange diameter, subtract out of it the hub. So 120 minus 15, that's about 105. That's how much flat space I actually have. Now, since both of these are diameters and my rib's only coming out on one side, I need to cut all that in half. So I'm dealing with half the part instead of the whole diameter. Pretty simple math at this point. Now, how far out do I want that rib to go on the remaining space? I want to go about 75%, about 3/4 of the way. So I'm going to put in a times 0.75. So when I enter this, I'm not committing anything to my part yet. I'm just playing with my math. I'm looking at the results, 39.375. Currently, we're up here at 15. That send it out roughly two and a part times longer. So that's about where I want it. So I can kind of validate my math before I commit to anything. Now that I like the results that I see, I just come up here and say this hub diameter, instead of 15 millimeters, it's going to be that rib length formula that I just typed up. So when I hit done, what did I do here? Rib length formula. millimeters. I know if I do this a lot, I forget to capitalize my first letters. Well, the number's coming up right. Oh, I'm putting it in the wrong field. No wonder it doesn't like it. I need it here where the rib length is. It's 25. I'm going up to 39. I'm not paying attention today. So list parameters, rib length formula. Now it's happy with it. Yeah, it's amazing what happens when you try to shove it into the wrong box. All right, so now if you take a look at the part, I've got the ribs coming out 75% of that flat area. I always like to test my work. I'll set that to 80. Take a look at it. Yep, they're about 75% out. Let's go back to 120. And everything's working fine. So again, don't be afraid to put a little bit of math into your parts. Now, we've got the ribs sticking out. What about the holes? We've got all this flange space out here. It'd be nice to move those holes out, basically in respect to the ribs. So I'm going to look at the holes and see, what do I need to do to expand them out a little bit? So I'm going to come in here. Let's find our holes. Right there. And by the way, I could do it in the sketch like I did earlier. I'm also going to show you, you can rename your D numbers here. So I could basically come out here and say bolt hole. They're based on a bolt hole circle. That circle currently is 50 millimeters. So it's based on a bolt hole circle. So let's go down here and do some more math. Add another user parameter. And we'll just call this our hole formula. This one's going to be fairly easy. I don't even think I need parentheses. That's basically the flange diameter times the 0.75% that I used up here. Flange diameter times 0.75 comes up with 90. 90 is bigger than 50. It sounds about right. That should send them out here about where the tips of the ribs are. So let's tie it in. This is now going to be based on my hole formula. And now the holes are out there at the tips of the ribs where I want them to be. So you can do a lot of mathematics. And again, doesn't hurt to ever test. If I want to send this back to, where did we start? 80. You can see that the ribs and the holes are still spaced accordingly. If I drop it down to 60, they should drop inside even further. Yep, so they're doing exactly what I want them to do. But just taking a couple minutes to write up a couple formulas and actually plug them into your parts, you now have a part that is parametrically smart. So you want to at least take your dumb parts and put a little math on them to make them smarter. All right. Now, there's actually one other issue with this. We have a parameter in here, or an equation, a dimension, that is designed for the hole spacing. I believe we'll call this the hole angle. That hole angle, or actually that would be the hole count. Right now we've got 4 holes. Let's change it to 6. And you'll notice when I get in here, the holes are shifted and they're not centered between the ribs anymore. Well, whoever designed this, they came in here for these holes and they just simply put a dimension of 45 degrees away from the rib. Well, if you've only got 4 ribs and they're 90 degrees apart, the 45 degrees makes sense. Well, what if you go to 6 ribs or 8 ribs or 10 ribs or 12 ribs? This angle is going to constantly be changing if you want your hole to stay in the middle of the ribs. So I need to figure out some sort of mathematical equation for that dimension, D9, so I can basically make it smart. So let's take a look here. D9, we're going to come in here and just call this the hole angle. I always like to put a name on it. If I'm going to start messing with it, I name it. That's just standard practice for me. Again, you can name it in a sketch. You can name it here. It doesn't matter where you name it. You can give it a name. So anything that is becoming important to me, I'm putting a name on it. Anything I do that is mathematical based, I typically don't do it up here. I put it down here under user parameters. So we're going to add another formula. This is going to be our, the holes are called a pattern. So I'm just going to call this our pattern formula. You can name these anything you want. It's going to be a pattern formula. This is based on degrees. I'm actually replacing this right here. So what kind of formula am I going to write here? Well, we know the hub is 360 degrees. 360 degrees. And we are going to divide that by our hole count. So if we've got 6 holes, we're taking 360 divided by 6. Now, unfortunately, the holes in the ribs are using the same dimension. So I've got to divide that in half. Should end up around 30 degrees. Little hint, if you ever get red in here, because I'm doing degrees and counting, just put a UL in there and it'll be happy with it. So yeah, came up at 30 degrees. So right now our hole angle is at 45. That's kind of a problem. 30 sounds right for 6 degrees, for 6 holes. So the hole count, that'd be right here. Hole angle, I just need to put our pattern formula in here. So if I condense all this, you can see which dimensions have become important in this part. And you can see all my formulas self-contained down here. So long story short, I'm doing all my math down here before I commit. I like to see my answers. Once I get the answers I'm looking for, then I just push it up here and put those formulas up in here. So let me expand this back down. So there's a ribbling formula. There's the hole formula. Hole angle, that's going to be our pattern formula. It didn't take, did it? You do have to accept it. Okay. So, done. That looks pretty good. Again, never hurts to test when you get into math or when you actually apply your goods. I'm going to come in here and say, okay, let's go to 80 on the hub. Diameters are all working out well. Let's go down here and tell it we want 12 holes. That's looking good. It's dividing up evenly. Let's go to 8 holes. Looking good. How about 6? Oops. How about 6? Looks good. How far down can we go? Can we go to 3? Using my number pad here and it's not registering. There we go. Yeah, I can go down to 3 ribs. I can probably drop all the way down to 2. Not that I would do a hub with 2 ribs, but we'll start with 3. Now, a lot of times, as you're adding intelligence to your part, let's take it one step further. There are cases where 3 ribs is working fine, 12 ribs is working fine. What happens if one of your users comes in here and types in something like 20 ribs? You could start getting errors. Why is it having trouble with 20 ribs? Well, there's not enough room for that. They're getting too close back here at the hub. There's not enough space to put the fillets in. You just start having issues, okay? So how do you tell your users which numbers are valid to put in and which ones are not? What if somebody comes in here and just puts in 14.5 ribs? That doesn't make any sense. You can't put in 14 and a half holes. It apparently rounded it off to 14. But yeah, how do you control your users? Real simple. Most people don't know this, but it's so easy to do. You can right click on any of these. You can do it down under user parameters. You can do it up under your model parameters. But you can right click and make it a multi-value parameter. When I say make this multi-value, you can make a list. 3 is acceptable, 4, 5, 6, 7, 8, 9, 10. Let's say when you get up to 10, you want to start spacing them a little bit. You don't want odd numbers. Maybe we want to go 12 and 14. You can pick and choose exactly what values you want to give the user to choose from. We'll let them go as far down as 3. We'll let them go up to 14. If they try to type in the unlucky 13, it won't let them. It's not on the list. So I've got these in the order that I want them, small to largest. That's a custom order. If you turn on allow custom values, they can still type in something that is not on the list. So you can add a little flexibility in here if you want. I usually don't. So we'll add that to the list and we'll say okay. And notice now you've got a pick list. So I could have 4 ribs. I could have 6 ribs. I could go up to 10. I want to double check and make sure I can go to 14 without it crashing. Yeah, 14 is acceptable. So I've given them a list of acceptable values that they can put in. And they all work. Let's just end up with 8. Now, why would I do this? Well, consider where we started. I started with a part that had 19 dimensions, and if I wanted to change anything in the part, I pretty much had to go line by line making changes. Now I've got a smart part here where I can change the diameter of the flange, let's say 120. Everything updates. I can come down here and say I only want it to have 4 holes in it. Everything updates. The ribs and holes are expanding themselves to stay proportional to the plate. So if I drop back down to 80, you'll see the holes and ribs all come in. If I drop down to 60, they come in even further. So I built a lot of intelligence into the part, and none of this required programming. Yes, it required math, but it did not require programming. That's what I like about Inventor's intelligence. So this is kind of level 1.